morning, my dear Prep 1 students. Hope you are all fine today. In today's lesson, we are going to have more examples on adding and subtracting rational numbers. But before we go and start solving more examples, let's first go and remember some tips that will help me while adding and subtracting of rational numbers. If I have, for example, the two rational numbers 5 over 8 plus 7 over 8, and I want to find the addition for both of them, simply I go and look at the denominator. If I have the same denominator, that's great, because I will have my denominator the same, which is 8, and add the two numerators, 5 plus 7, and I will have now 12 over 8. And remember, always you must put your answer in the simplest form. So 12 over 8 is equal to 3 over 2. What about if I don't have the same denominator? Oh, this is a problem. Why? We said while we are adding or subtracting rational numbers, I must have the same denominator. Simply, if I have different denominator, go to the smallest one and ask, can 4 be changed to 8? Yes, it can. How? By multiplying both the numerator and the denominator by 2. So I will result now having 2 over 8 plus 25 over 8. Yes, that's great. I have reached the same denominator. And my answer is going to be 2 plus 25 over 8, which is equals to 27 over 8. And this is the simplest form. Again, let's take another example. What about if I have again two different denominators, but I don't want to change the 5 to be 10? We can easily go and do cross multiplication. Simply by multiplying 10 times 5, I will have a new denominator of 50, and then cross multiply 5 times negative 3, and don't forget the negative 3, it's negative 15, and the operation I'm going to move it as it is, which is plus 10 times negative 2, and don't forget again the negative. So I will have now negative 35 over 50, and still I can simplify this rational number by dividing both the numerator and the denominator by 5. As a result, I will have negative 7 over 10. Those were the main three ideas in the previous lesson. What about if I have a mixed number? I cannot add or subtract mixed numbers unless I change it first to be an improper fraction. How can I change the mixed number to an improper fraction? Simply multiply the whole number times the denominator, so 3 times 6, which is equals to 18. Add your answer to the numerator, so plus 2, 18 plus 2, which is equals to 20. So now I will have my improper fraction as 20 over 3. And keep in mind and remember that we keep the denominator the same. Now, after I knew the 4 important tips that I can use while adding and subtracting rational numbers, let's go now and take more examples. The first one is 8 2 over 3 plus negative 5 1 over 6. We said that to add or subtract mixed numbers, first we must change them to an improper fraction. So, my two new improper fractions are 26 over 3 plus negative 31 over 6. Have a look here at the denominators. I have 3 and 6. They are different. I will go to the smaller one, which is 3, and ask, can 3 be changed to 6? Yes, simply by multiplying both the numerator and the denominator by 2. And as a result, I will have 52 over 6 after I multiply the numerator and the denominator by 2 plus negative 31 over 6, which is equals to 21 over 6. We go, have the same denominator as it is, and add the numerators 52 plus negative 31, which will give me 21 over 6. And remember, 21 over 6 is not in the simplest form. Still, I can divide both of them by 3 and have 7 over 2. Let's go now for number 2. 4 plus negative 9, 5 over 8. Here I have a whole number and a mixed number. So we must change them both to fractions by putting 4 over 1 and changing the mixed number to an improper fraction. So 4 over 1 plus negative, multiply the denominator by the whole number, which is 8 times 9, and the result I will add it to 5. My two new rational numbers are 4 over 1 plus negative 77 over 8. By looking at the denominators, I have here different denominators. I will go to the smaller one and ask, can 1 be changed to 8? Yes, simply if I multiplied numerator and denominator by 8. My two new rational numbers are 32 over 8 after I multiplied numerator and denominator by 8, plus negative 77 over 8. How can I add those two rational numbers? Simply, I'm going to have the same denominator, which is 8, and the numerator is 32 plus negative 77. It's negative 45 over 8, and this is in the simplest form. Let's go now for number 3. Negative 8 1 over 3 plus negative 4 1 over 12. Again, they are mixed numbers. I must change them to an improper fraction. So I will have negative 25 over 3 plus negative 49 over 12. By looking at the denominators, I can see that they are different. So I'm going to go to the smallest one. Can 3 be changed to 12? Yes, simply by multiplying the numerator and the denominator by 4. I will have now negative 100 over 12 by multiplying the numerator and the denominator by 4, plus the same fraction, which is negative 49 over 12. Now I have the same denominators, so my denominator is 12 is negative 100 plus negative 49, which is equals to negative 149 over 12, and this is in the simplest form. I would like you please to pause and write those examples in your classwork copybook, and then come to complete. Question number 4 is 50% plus 1 over 4. How can I add a percentage to a rational number? Simply by changing the percentage to be a rational number as well. We said that percentage mean a part of 100, so I am taking 50 out of 100. 50 over 100, and this is the rational form for 50% plus 1 over 4. Adding and subtracting rational numbers, I must have the same denominator, and the denominator here is different. 100 and 4. Going to the smallest, can 4 be changed to 100? Yes, simply by multiplying numerator and denominator by 25. So, 50 over 100 plus 25 over 100, and by having now the same denominator, my denominator is 100 and my numerator 50 plus 25, which is 75. But keep in mind, 75 over 100 is not in the simplest form. The simplest form is 3 over 4. And if you don't know that you should divide both the numerator and denominator by 25 to get the simplest form, simply you can go and put 75 over 100 in your calculator and press equal, and you will find the simplest form. Let's go now for number 5. 12 over 18 plus 5 over 9 plus 1 over 3 plus negative 15 over 27. As you can see here, I have the 4 rational numbers with different denominators. So I must find the LCM for all of them. How to find the lowest common multiple, or the LCM, for the numbers 18, 9, 3, and 27. First, we should know that to find the LCM, we must do prime factorization. And we do prime factorization by dividing the given numbers on prime numbers. Remember, my prime numbers are 2, 3, 5, 7, and so on. So let's go now and begin with number 18. To do the prime factorization of 18, I'm going to divide 18 by 2. 18 divided by 2 is 9. What is the prime number that I can divide 9 with? It's 3. 9 divided by 3 is 3, and 3 divided by 3 is 1. When I reach 1, this means that I have already found all the prime factors for the number 18. Let's go now for the next one, which is 9. 9, I'm going to divide it by 3. 9 divided by 3 is 3, and 3 divided by 3 is 1. And again, since I reached 1, I have already found the prime factors for the number 9. Let's go now for the number 27. 27, I'm going to divide it by 3, and I will have 9. 9 divided by 3 is 3. 3 divided by 3 is 1. Now we should go and write what were the prime factors of 18. It's 2 times 3 times 3. And what are the prime factors for 9? It's 3 times 3. 27 is 3 times 3 times 3. To find the lowest common multiple, I'm going to take one from each row. So let's have a look here. I have 2, 3, 3, and 3. So I'm going to take only 1, 2 times 1, 3 times 1, 3 times 1, 3, which is going to give me 54. My lowest common multiple for those numbers is 54. My LCM here is going to be 54. So my four rational numbers are 36 over 54 plus 30 over 54 plus 18 over 54 plus negative 30 over 54, which is equals to 54 over 54, and any number over itself is going to equal 1. Let's go now for number 6. Absolute value of negative 5.5 minus 1 over 4. Remember, we said that an absolute value of any negative number is the same number but positive. So I will have 5.5 minus 1/4. Having a mixed number, I must change it first to be an improper fraction. So my improper fraction is simply 2 times 5 equals 10. 10 plus 1 is 11, so it's 11 over 2 minus 1 over 4. Let's now have a look at the denominators. 2 and 4. Both of them are different, right? So go to the smallest one, which is 2. Can 2 be changed to be 4? Simply by multiplying the numerator and the denominator by 2. I will have now 22 over 4 minus 1 over 4. Great. Now I have the same denominator. So my denominator is going to remain the same, and 22 minus 1, which is 21 over 4. And this is my final answer. Number 7, negative 2, 2 over 5, minus 12. Again, I have a mixed number and a whole number. We said that we must put them both in the form of a over b. So the mixed number is going to be changed to an improper fraction, and the whole number I must also to put it in the form of a over b. 5 times 2 is 10. Plus 2, 12. So negative 12 over 5 minus 12 over 1. Having different denominators here, so 1, how can I change it to 5? Simply if I multiply numerator and denominator by 5. My two new rational numbers are negative 12 over 5 minus 60 over 5. Here I have now the same denominator, so it's easy to subtract the two numbers. So my denominator is 5 and my numerator negative 12 minus 60, which is negative 72. And this is the simplest form. I would like you please now to pause and write those questions in your classwork copybook and then come back to complete. Let's go now for number 8. Negative 5 over 6 minus negative 3 over 4. Again, I have here different denominators, 6 and 4. And I'm going to ask myself, can 4 be changed to 6? No, I cannot change 4 to be 6. So simply, I am going to find the lowest common multiple between both of them, and it's 24. So I'm going to let the denominator of both my rational numbers 24. I multiplied here by 4 to have the denominator 24. So 5 times 4 is negative 20. And I multiplied here by 6 to have my denominator as 24. So negative 3 times 6 equals to negative 18. Now it's easy, while having two same denominators, to subtract two rational numbers. 24 will remain the same, and my numerator is negative 20 minus negative 18. So it's equals to negative 2 over 24, and the simplest form is negative 1 over 12. That's great. Let's go now for number 9. The remainder of subtracting 3 over 7 from 9 over 21. So I'm going to take away 3 over 7 from 9 over 21. 9 over 21 minus 3 over 7. And by looking at the denominators, I'll find that they are different. Simply, I'm going to go to the 7 and ask, can I change the 7 to be 21? Yes, if I multiply the numerator and the denominator by 3. So I will have now 9 over 21 minus 9 over 21. And my result is going to be equal to 0. Number 10, 0 minus negative 17 over 4. Remember, when we were in primary 6, we said that minus a negative number, this is going to be changed to positive. So it is 0 plus 17 over 4. And my final answer is 17 over 4. Subtracting negative 3 over 7 from 0 gives, this means that I am going to take away negative 3 over 7 from the 0. So it is 0 minus negative 3 over 7. We said that minus and a negative number, it's going to be changed to positive. So it is 0 plus 3 over 7, and my final answer is 3 over 7. 0 plus any number is equal to the same number as it. I would like you now to go and pause your video and copy those questions in your classwork copybook and then come back to complete. Number 12, put in the simplest form. 0.18, and this decimal is a recurring decimal. 1 and 8 is repeated. Minus 30%. So, to be able to subtract those two numbers, I must change them first in the form of a over b. By going and using my calculator, 0.18 and this 18 is repeated, I will have it equals to 2 over 11. And remember, I do this by using my calculator. I type 0.18 and keep repeating the 18 till the end of the screen, press equal, and I will have the rational number. What about 30%? We said that a percent is a part of 100, so I am taking 30 out of 100. 30 out of 100, when I'm going to put it in the simplest form, it's 3 over 10. I am making 2 over 11 minus 3 over 10. By looking at the denominators, both denominators are different. And I cannot change the 10 to be 11. So I'm going here to use the cross multiplication. 11 times 10 is equals to 110. 10 times 2, 20. The operation, which is subtraction, will remain as it is. 11 times 3 is equal to 33. Now I will have my answer equals to negative 13 over 110, and this is the simplest form. So again, to subtract the numbers, I must put them first in the form of a over b. And this is so easy. For a recurring decimal, to use it doing a calculator, and 30% or any percentage means the number over 100, and then do my subtraction normally. Pause the video please and go and copy this question in your classwork copybook and then come back. The last question in today's lesson is number 13. If A is equal to 3 over 4, B is equals to negative 5 over 2, and C is equal to half. Find number 1, A minus B, number 2, A plus B minus C. What is the meaning of this question and how can I solve it? Simply, I'm going to take away the variables A, B, and C and put the rational numbers instead of them. So let's go first for the first one. A minus B. He told me that A is equal to 3 over 4 and B is equals to negative 5 over 2. So 3 over 4 minus negative 5 over 2. By doing cross multiplication here, I will have my denominator as 8. Also, you can change it by multiplying both the numerator and the denominator by 2. And 2 times 3 is 6. The operation will remain as it is. 4 times negative 5 is negative 20. My answer is 26 over 8. But remember, 26 over 8 is not in the simplest form. Let's go now for number 2. A plus B minus C. I'm going to take away A and substitute it by 3 over 4, B and substitute it by negative 5 over 2, C and substitute it by half. If I found in mathematics any bracket, I must first find the answer of the bracket and then add it to A. So this is 3 over 4, which is A plus, I know that both the denominators for B and C is 2. So my denominator is 2. And negative 5 minus 1. So I have here 3 over 4, which is A, plus negative 6 over 2. This negative 6 over 2 is the result of subtracting B minus C, which is negative 5 over 2 minus half. By looking now at the denominators, I can see that both denominators are different. Can I change the 2 to go and be 4? Yes, simply if I multiplied both the numerator and the denominator by 2. But I'm going here again to go cross multiplication. 4 times 2 is 8, 2 times 3 is 6, and the addition sign will remain as it is. 4 times negative 6 is negative 24. It's equals to negative 18 over 8. And remember, negative 18 over 8 is not in the simplest form. Still, I can divide both of them by 2, and I will have negative 9 over 4, and this is the simplest form. By now, we have finished adding and subtracting of rational numbers. In the next video, we are going to explain the properties of addition and subtraction of rational numbers. I would like to thank you all, Prep 1, and have a nice day.